And what's that you say? We actually only measure the plate, and depictorially you say there's a second plate that goes through the middle of the ball. So there's 2 plates.
G'day everybody, Where's Wally here. Today we will listen to Nathan as he goes up an octave or two. Why listen to Nathan, I hear you ask? Because, well, we all need a laugh in our lives, don't we? So let's have a listen to Nathan at his straw man smashing dog whistling finest.
In your ball world, what's with the plates? Stuck on top. Surely you'd just measure it as a ball if it was a ball. You wouldn't stick a plate on top of it.
Measure it as a ball then? Okay Nathan, you're such a genius, how would you do that? Well, I mean, I know how to. I've done so. But please, Mr. Super Genius, tell us all. How would you measure the globe? Now, I predict a whole lot of why would I? Excuses and chanting. And that's exactly what I got later in the day from him. And I got a special mention in his last show as well, so I'll put that at the end of this for your enjoyment.
In the 5,400, what they're categorically stating there is that every degree of star change is attributable to the angle of rotation. The further away from it you are, the further you're tilted away from it. So that the relationship of angular star change is only Earth curvature.
Well, I do love that they know that there are 5,400 nautical miles from the equator to the pole. That has to be generating a whole lot of cognitive dissonance when they excuse away that fact.
You can't measure it from this part, this curve. Doesn't work. Angles don't work that way.
Further to that, if go back. If you're working off this plate, yeah, and we've got the observer described as being at the very top of this ball on this plate that's being actually measured and utilised with 90 degree at the zenith position of the observer.
Well, yes, it is a theoretical plane. It's not just an actual plane that you can touch. It's a tangential horizontal plane 90 degrees from the local vertical. How hard can this be?
There could be, very realistically, a second observer on a ship out here.
Out there? So a spaceship then, is it? But you don't even believe that you can go to that region, Nathan. Wow, you're really going huge straw man on this one, aren't you?
Now he's going to perform the same measurement from his zenith position and triangulate with the star that just happens to be below the guy that we mentioned that's coincidentally depicted at the top of a sphere on a plate. So therefore, the guy who's doing the exact same triangulation with 90 degrees to his positions also debunking this sphere below, because he hasn't got the sphere below. There's just empty space below him when you depict it in this manner. But he's still going to do the exact same measurement and triangulate his position with 3 stars to a flat plane beneath where he's standing here.
Oh, this is great, Nathan. You realise you just debunked all of celestial navigation on a flat Earth right there, don't you? You don't? Oh, well, okay, let me explain why a sextant would not work on a flat plane. See, you started with that guy at the zenith. We'll call him Zenith Guy. And he has a star directly over his head. That's correct. Now, Starman out there in Red Tesla, we call him Guy 2, he's on the same plane as Zenith Guy. He will see the star also at 90 degrees to the plane. So how is anyone on a plane seeing any difference in the elevation angle to the star? Remember, 1 nautical mile is 1 minute of arc difference in elevation to the angle of a star. What is the angle that he should see the star at if Guy 2 was right above the outer edge of, let's say, 1R from Zenith Guy? Well, that's 3,440 nautical miles away. That is 3340 arc minutes. So how do we get degrees from arc minutes? We divide by 60, don't we, Nathan? That's 57.333 degrees. So if the star viewed from Guy 2 has to be 57.33 degrees above Guy 1, how far is it above Zenith Dude? Well, triangle calculator, please. We'll put a 90 degree here, 3340 here, 57.33 here, lose these, 5,365 nautical miles above Zenith Dude. Yeah, that ain't right, is it? So the star can't be local. It has to be far away.
In other words, the only thing that works is if you keep all of the area that's being measured and triangulated upon flat.
You can't do that on a flat plate, mate.
For every single observer. Because only one can line up with the zenith position and presupposed centre of this Earth in this depiction.
So what actually happens is a ship goes around the surface. It sails away from Zenith Guy. Now, Guy 2 has his zenith here, and that is the line from the centre of the Earth to him, and above. So what a sextant will do is measure the angular separation between 2 points. Those are Zenith Guy's star and either the horizon or the vertical. Let's use the vertical, as when you use the horizon, you change it to the co-angle vertical anyway. I think any thinking person can see now that the further Guy 2 goes away, the further around the curve and the greater the angle. And the angle in arc minutes is nautical miles between Guy 2 and 10thMan. Sorry, that got a bit long-winded, but Nathan will like that as he is long-winded personified. Now let's just keep listening to Nathan, being long-winded as he tries to strawman sextants on a globe and fails continuously.
The guy who's standing on the edge of the plate, teeter-toppering the top of the sphere Earth we don't have, he's also going to be capable of making the same measurement.
Yes, Nathan, the same measurement returning the same angle value is useless. How can you navigate when you measure the same angle no matter where you are on the plate Earth?
Good point. They have one, of course, in a image of a sphere, but this is what anyone on this circle
Doesn't work. They don't have
Doesn't work
90 degrees to their
that's a
zenith.
joke.
This doesn't work.
Yeah,
They don't have 90 degrees to the zenith positions of these stars. This isn't triangulatable.
What do you mean they don't have a zenith? Are you telling the truth there, Nathan? Oh, I hate that diagram. The cones of fail, I call them. This is what it actually is. The red light from star A is parallel all over the planet and is only a zenith line at one place, the GP of the star, and that is the centre of the circle of equal altitude that it forms. The same goes for the green light from star B.
I'd like to bring to everyone's attention that if you are sighting a star at the horizon and it's 54 nautical miles away, that's just a radius. It's really 10,800 miles of flat.
Wow.
Does anyone know what 10thMan is banging on about there? By 54, I assume he means 5,400 nautical miles, as in a quarter of the circumference of the globe. Anyway, listen to how quickly Nathan seizes on the chance to get into the safe place.
Okay, on that subject, Neil, because you asked and it's a nice segue.
Anyway, listen to how quickly Nathan seizes on the chance to segue to the safe place. This talk of celestial navigation is a little too close to the globe for him, I think.
How do they hide it in the language? You personally describe people who would justify...
Yeah, I'm bored with Nathan playing word games. Let's skip that. Now, I found these gems a little earlier on in the show. I must have missed them.
So 5,400 nautical miles. So let's go back to the image. This is a right angle. There's your 90 right here. Everyone see this? The line should be right here.
Yes.
Okay, that's 25% of the Earth, Adam.
5,400 nautical miles is 1/4 of the circumference, as 10thMan incredulously informs us. Nathan is treading very carefully here. Not because, as he claims, I don't want to undermine 10thMan. We all know Nathan would throw his best friend under the bus.
That you're able to see with no curvature blocking something.
All flat.
How can that be possible on a curved Earth?
Completely impossible. I'm sorry, what I just said a second ago, I meant to say celestial refraction, not celestial navigation. Right.
So they would have you believe that when the sun is at the horizon at sunrise, the subpoint of the sun is 5,400 nautical miles, and your sextant can catch. Of course, you have to put the refraction corrections in it because it's below 15 degrees. But once you do all the corrections, they're basically telling you that 5,400 nautical miles is your distance to that sunrise GP, the GP of the sun as it's rising somewhere over the Earth. That would mean that C to here would give you that right angle, that 90, and you're able to see from here over here. What about this? How come this isn't blocking anything? That's 25% of the Earth that doesn't block anything.
10th man, here is the correct diagram. This will help you understand. It's actually 50% of the surface that can see the sun at any one time. You know, daytime. I have no idea what he's banging on about this 25% and blocking. He seems confused once again. And this is the Flat Earth Sextant expert talking here.
But that's the geometric horizon that we were discussing in the pre-show that Roohif is claiming we now have, even though we've had 2 straight years of this being told that we don't have a geometric horizon. So, what are they fighting for? This obstruction that you're asking now why it's not getting in the way? Well, I'll answer you. Because we've debunked that as a physical geometric horizon from a sphere formerly known as Earth curve. The Black Swan debunked that. So when they go back to asserting that they've got a geometric horizon and you say, well, if you did have a geometric horizon, I know that you're pointing this out from their books, but you are sidestepping the Black Swan.
Sidestepping the Black Swan? Quoting from books that FE used to claim that they can do celestial navigation with a sextant? Seems the year of the sextant is getting a little bit shaky there, hey Nathan? Maybe you better consider that those books you are sidestepping are debunking the Black Swan nonsense. Have you ever thought of that?
You don't need to expect. I'm trying not to undermine what you've just said. I really am, I promise. But Black Swan.
No, go ahead.
Well, Black Swan.
Go ahead.
Black Swan. Don't
No,
need to ask them why their geometric horizon isn't getting in the way when you've got 5,400 nautical miles of flat plane that you can measure 90 degrees to. Well, when you've got that...
I love it when Nathan gets all stammery and hesitant as his brain is buffering. The problem he is suffering right now, his cognitive dissonance is real for him at this point.
And they say, well, no, we've got a sphere beneath our feet. To then take that to, well, no, because the sphere edge horizon that you say is beneath our feet would be in the way, given this area of flat land. It's like you shouldn't be into that argument because of the Black Swan. The fact that someone like Roohif, in this example, has stuck his head in the sand for 2 straight years and is now saying it's geometric.
And the nervous laugh of defeat is real too. Thanks, Nathan. Love it.
It's just laughable.
Well, that's both sides of the argument. Law of non-contradiction. They live on a flat plane. They know it because the sextant can't work with a curved adjacent.
Exactly. How'd you get this elevation angle in the first place?
How did I get this elevation angle in the first place? When I used an Uber sextant, but you won't understand how that it is referenced to the celestial sphere. Let's just say I did whatever 10th man did when he measured an elevation angle to a celestial object and used that elevation angle for his flat Earth celestial navigation. That's exactly what I did.
You're not measuring from the centre of a presupposed spherical Earth with an R value also debunked by the Black Swan, as Adam pointed out earlier. This necessitates the measurement of that sphere beneath the flat line that you're actually measuring. Well, have you got that? No, that went the way of the dodo too, with the Black Swan.
Now, Nathan realises that celestial navigation is causing a problem for the Black Swan. Nathan, to his credit, can see celestial navigation, the new thing they have been championing all 2021, the year of the sextant, is killing the Black Swan. It's like you had 20 pet cats for all of 2020, and now you have a pet Burmese python. And he's loose in the house, and he's growing bigger and bigger every day, and oddly, you seem to have less and less cats to feed. Not sure why this is happening, Nathan. Oh wait, yes I do. Here is where you're at now. You have a choice. You have to cut one of these loose. You have to pick the Black Swan or celestial navigation year of the sextant. We will all wait patiently as one destroys the other. Which will you pick, Nathan?
Need to go back to 2015 and say, oh yeah, Earth curve gets in the way of this here boat. It's like, hello, we're still here. Yeah, we've debunked all that crap. You've been telling us it's refracted for 2 years. But what, you need to now forget all about that and go back to calling it a geometric edge blocking boats? Yeah, that's going to leave a sting, isn't it? Yeah, we know it. Well, we're all sitting pretty, none of us care in that regard. But when you're telling us, well, I would approve it then, as Wally did in one of my comments earlier on today, when he's asking me how would you go about proving it can be measured with a curve adjacent, Nathan? I wouldn't, Wally. I don't care about how you get around your troubling issue of not having the capabilities of doing any trig with a curved adjacent. You can't. That's not my problem, though. I'm not going to give you the answers. You share your pain with us, Wally, in the comments. Just continue to do what you're doing.
Nathan completely missed the point of why I asked this question. I know how to do it. I have done it. I'm just wanting to know if he could do it. No, of course he's not willing to talk about it. He knows I'm well capable. But on the curve adjacent silliness, this is something going right over the heads of the FE Sextant proficient. We are not measuring from a curved baseline, nor are we measuring from a flat baseline. When you use a sextant, you measure angular separation between 2 points. So there's only 3 points involved, no baseline of any sort, shape, colour required at all. Now this is why you can use the sextant on its side to measure the angular separation between, let's say, a lighthouse and the headland, for example. If you know the distance between those two by, look at a map, you can then work out how far you are from them by the size of the angle between them. We all remember Nathan's axiom, shit shrinks. Yeah, the further away, the smaller the angle. You're able to calculate how far from the coast you are by looking at the angular separation between the lighthouse and some other object. And if you're able to do that with another pair of objects, you would have two distances. You can now use trilateration to calculate your exact position. Fancy that. Oh, so there's an even better way of explaining this to Nathan. You know 10thMan, right? You know how he's good at celestial navigation, right? Well, he says he is. You know how he measures angles of elevation to celestial objects, right? Well, I just do what he does. If you don't believe me, Nathan, I challenge you to ask 10thMan, would he have measured the same angles of elevation to the star at Dubbo or at Sydney that I measured? And if he would not, can you explain why not? Because we all know he would have measured exactly the same angle, perhaps just a little less accurately than my Uber sextant. And if that is the case, and we know it is, then we might just have to, revisit this conversation about my R proof once again. Hey Nathan. Thanks guys.